So the question we're trying to answer here is, why do supernovae happen, as in type 2 supernovae? So the one you talked about here. And it's related to these three forces, actually. One of the forces I mentioned in an earlier video isn't a force, but for the moment we're going to think about it as it is a force, so gravity. Okay, gravity, according to Einstein, is not a force. According to Newton, it is a force. We're going to imagine it's a force at the moment. And so we know that in a star we have two forces. We've got an inward force of gravity, and we've got an outward force from the fusion reactions. So we've got these forces that are pulling it in. All of the stuff that the star is made out of is being attracted to itself. It's with such a high force that it's all being pressed together, and because of that, fusion is allowed to occur. And fusion is a reaction that produces lots of energy, and so much so that it produces a kind of an explosive force, which would cause an outward force. So we've got this outward force from the fusion reactions and this inner force of gravity. But we've actually got a third force, or two more forces that we want to be thinking about as well, which are only really thought about at very close levels. And that is the electromagnetic force and the strong nuclear force. So all atoms, all stuff that we know of, is made out of atoms, and all atoms are made out of protons, neutrons, and electrons. The nucleus of the atom, which is what makes up most of the atom, is made out of the protons and the neutrons. The protons are positively charged, and the neutrons don't have a charge; they're neutral. So inside the nucleus, it's either positive or it doesn't have a charge. So first of all, we need to realize that it's a bit of a mystery how the nucleus stays together at all, because it should be blowing itself apart. And this is why fusion doesn't occur at lower temperatures, lower pressures. If I try to, in fact, let's get rid of that. Okay, cool. So if I try, let's imagine these two are protons, I wouldn't be able to get them near to each other because they would repel each other. That's the electromagnetic force. However, there's this strong nuclear force that once you get close enough, they do in fact suddenly, the strong nuclear force is actually attractive, and way more attractive, a much stronger force than the electromagnetic force. So once you get close enough, the protons are quite happy to stick next to each other. So it's a little bit like this concept down here of two magnets, two north poles sticking together because they've got some Velcro there. The Velcro is stronger than the magnetic force, but if the magnet didn't get close enough, they would repel, and the Velcro wouldn't be able to do its effect in the same way as the strong nuclear force. It only works once it gets close enough. However, the strong nuclear force is in fact repulsive once you get even closer than that. So after a red giant stage, everything comes rushing back in. If the star's particularly massive, then it's going to be rushing in at a faster and faster speed, because the strength of gravity is going to be really, really high. And so the atoms won't just have this force. So this is the bit that I'm sort of hypothesizing myself. Okay, so everything else I've said so far you'll find in all the textbooks. This bit I haven't read myself, but it probably is the case. So basically, as the atoms come rushing in, my theory is that they not only get close enough to be able to touch, but they get even closer, or close enough to be able to connect together. They become particularly close, such that the strong nuclear force is now a repulsive force. So it's a little bit like a bouncy ball when the ball it doesn't just reach the ground and sit on the ground. It slams into the ground with such a force that the bouncy ball compresses, and then there's this repulsive force of the bouncy ball bouncing off the ground. So the strong nuclear force becomes a little bit like that, because it's beyond a certain closeness. The strong nuclear force is in fact repulsive, and so so my feeling is that's why it suddenly and shoots back out again. That's my theory. Okay, so that's my guess at why supernovae, type 2 supernovae happen in the first place. Okay, you can research it, see if I'm correct, but I haven't actually found a reason myself yet.